With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, here the assertion says that the time constant of circuits shown in the figure are same. Reason says that the instantaneous current through the capacitor branch is same at any instant for both the circuit if the batteries are inserted at t equals to 0 in the circuit. So if I calculate the time constant, for that we have to short this battery. So just short this battery. So after sorting the battery, you will calculate the R equivalent across this capacitor. So if you see, R1 and R2 are in parallel, and since we removed this battery and we connected this with a conducting wire, then this R1 and R2 is also in parallel. So we will write down R equivalent is equals to R1 plus R2 in division R1 plus R2. So if I write down the time constant, it will be equals to C into R equivalent, and yes, it is same for the two, right? So this is completely true. Moving ahead. So instantaneous current through the capacitor. So if I talk about the instantaneous current, we know that in case of charging, the instantaneous current is maximum into this. So Q maximum, if you see here, the Q maximum will be when the current through the capacitor will be 0, right? At Q is equals to Q naught, the current through I through C will be 0. So no current will flow through the capacitor, right? So what will be the potential difference across that? If I say this is V and this is V, what will be the potential difference across that? So if you see in this case, it will be V only, right? It will be V only. Alright, and if you see here in this case, here the capacitor is connected like this, but the current flow through this R2, right? So the potential difference will be same as that of the potential difference across the R2. That will be I into R2. I will be V by R1 plus R2, right? So in the two cases, if you write down the Q01, it is simply this. In the second case, we already have seen it is C. If you see, it is IR2. So we'll write down C into the potential difference across that is IR2, and I is V by R1 plus R2 into R2. So you can see the Q0 is not same. The Q01 is not equals to the Q02. Though the time constant is same, but the maximum current is different. So the function of this charge at any time will be different, right? So you can also write them down. It will be, for the first case, it will be Cv into 1 e to the power, and in the second case it will be this, right? Initiating it, you will get the current through the capacitor as well. That will be this. So if you see, it is Cv e to the power minus t by tau. So minus it will become plus, right? In division, it will be tau, that is this. And similarly, you will do the same. So you will write down it is Cv R2 by R1 plus R2. Here in division, again we'll write the same. It is C by R equivalent. So R equivalent is R1 R2 by R1 plus R2. So if you see, this R2 will get cancelled out and R1 R2 will also get cancelled out, and you will write down here it is into R1 R2 by R1 plus R2. So it is this into this, and at any instant the current through the second capacitor, you could already see that this C and C got cancelled out, and we are left with, if you see, it is V by R1. This. So certainly no, they are not the same, they are not the equal. But in this reason, it is said that they are equal, they are same, which is not true. Assertion true, reason false, C is the correct. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.